All right, team, gather round. Today, we're going to talk about the one principle that, really, it governs everything we build. I mean everything, from the simplest little sequence to the most complex, self-contained system. This is the secret, you know? It's how we make things that aren't just functional, but predictable, reliable, and, yeah, even beautiful. So let's dive in.
I want you to just think about this for a second. Seriously, what could these two things possibly have in common? On one hand, you've got a masterpiece of natural engineering, a product of millions of years of evolution. And on the other, a device built from pure logic, designed for digital security. So, what's the connection?
Well, the answer is right here. It's all in the structure. See? On the left, a perfect spiral, totally governed by a mathematical sequence. And on the right, a perfectly organized file system for our secure computing node, the hexacodex. Both of them, believe it or not, are built on the exact same idea, separating the plan from the parts. And that idea, well, that's the core of our whole lesson today. This separation of the index and the value. This is the master blueprint behind every single ordered system, and it doesn't matter if it's grown in nature or compiled by one of our machines.
Okay, so here's the crucial point. We have to always distinguish between a thing's location and the thing itself. The index, that's the where. The value, that's the what. Now this might sound super simple, but I'm telling you, getting this right is the absolute key to creating systems that don't just fall apart under pressure.
This slide, it breaks it down with some really great analogies. Think of it like this, right? The index is the address, and the value is the house at that address. Or the index is the layer number in some cool pattern, and the value is how many dots are in that layer. The index is the step you take in a sequence, and the value is what you find at that step. One is the map, the other is the territory.
You know, here's the best part. We architects, we didn't invent this stuff, not even close. We just observed it. Nature has been using this exact blueprint for eons. The most elegant, the most resilient systems in the entire universe are built on this one principle.
Now, take a look at this. At first glance, it kind of looks like random noise. But what you're looking at is a profound piece of order. This is called an Ulam spiral. And those little black dots, that's the pattern of prime numbers. You know, the ones only divisible by themselves in 1.
So if you just list out prime numbers, they seem totally random. But the moment we assign each number an index, a specific coordinate on this spiral grid, and then we use primality as the rule for the value, do we put a dot there or not, suddenly this hidden geometric order just emerges. The index reveals a pattern in the value that was completely invisible before. It's amazing.
And we see the exact same thing with the famous Fibonacci sequence. We're not just listing numbers, 1, 1, 2, 3, 5, 8. No, we're using each number's position in the sequence, its index, as a command to generate a geometric value, in this case a square of a specific size. And that generative process is what creates the beautiful spiral.
So the big question is, how do we get from the natural world to the digital one? As builders, right? How do we actually harness this principle? Well, we translate these natural blueprints into formal logic, into code.
This is how we make it real, how we make it concrete. This bit of Python code, it defines a rule. For each position, each index n, it computes a very specific value. You can see it right there, generating pairs for stars, hexagons, and of course Fibonacci numbers. By explicitly creating these index value pairs in our code, we can build literally any pattern we want and do it predictably every single time.
You know, this same logic even defines what we hear as beautiful. In music, an octave is a sequence of 13 notes, a diatonic scale. That's when we pick 8 of them. A major chord is built on the 3rd and 5th degrees of that scale. Now look at those numbers. 3, 5, 8, 13. They're all Fibonacci numbers. The index, the position of a note in the scale, determines its harmonic value.
Okay, so now for the payoff. We take these universal principles of order and we apply them directly to our work. We're going to build a digital artifact, our hexacodex node, that is just as reliable, just as well-structured as those incredible patterns we see in nature.
This right here is a really crucial point. We're not just writing code anymore. We are manufacturing a product, a shippable artifact. And what that means is that it has to be complete and it has to be reproducible every single time. No ambiguity allowed.
You know, the end result of all this deep architectural work, it should be profound simplicity for the user. 4 steps: flash, copy, enable, reboot. That's it.
And this simplicity is only possible because we've built an incredibly rigorous and predictable structure underneath it all.
But how do we guarantee it? How do we prove that the artifact we deployed on that USB drive is exactly what we designed? We need a perfect map. We need a manifest.
This is the fundamental question of systems engineering. We can't just cross our fingers and hope it's correct. We have to prove it. And the proof is a map that explicitly connects every single location to its unique expected content. It's our index value principle applied directly to software.
And this is the tool we use to draw that map. This simple little command does something incredibly powerful. It goes through every single file path, that's every index in our system, and it uses a cryptographic function, SHA-256, to generate a unique digital fingerprint called a hash. And that hash, that's the value.
And this right here, this brings it all home. Just look at this comparison. An index n in a sequence gives us the value of a prime number. A note's position in a scale gives us the value of a perfect harmony. And in our system, a file path like system/setup.sh gives us the verifiable value of a unique checksum. It is the exact same principle, scaled from pure mathematics to music all the way to mission-critical software.
So I'll leave you all with this thought. This is the master tool, separating the plan from the parts, the index from the value. It's what allows us to build real complexity without creating chaos. It helps us make systems that are verifiable, resilient, and, well, elegant. The only question left is, what are you going to build with it?